all of you might have been informed that there's the Best Paper Award when we were announcing the program. Now, how did we select it? So I just talked a little bit about how it was selected. So every reviewer had an option to recommend Best Paper Award by what they saw in the review process, which goes into the track chairs, who looks at the whole of their tracks, gives a suggestion. But we as a conference committee again went through almost all of those selected papers to look at different pros and cons. And we did this analysis based on a couple of points. One, is this novel enough? It is very relevant for a computing and construction. Does it have a computing contribution? The second, is that computing contribution really contextualized for the sector we are in, with impacts both in research and also in practice? Then we looked at whether they followed a good research methodology with rigor, that it can be reproducible, and it could kind of have impacts, or we could all use it, learn from it. With that, we got into one paper, and I'm very happy to announce the winner of 2026 EC3 Best Paper, which goes to the paper Neurosymbolic Reinforcement Learning for Multi-Category Construction Relationship with Reasoning and Sequence Planning, authored by Akash Kumar Singh and Patrick Say from Department of Civil Engineering, National Taiwan University. I would like to invite Akash to this stage. Thanks. I would like to also tell a little bit of why we felt this paper was important. But before that, we're going to give the plaque to Akash. Yeah. So, winner of the Best Paper 2026 EC3. So we selected this paper primarily because it is looking at one of these important points in what we are seeing. We are seeing a lot of proliferation of AI, but we need sort of methods to kind of know that it's explainable and reasonable and also has impacts. And Akash here will talk more about the paper. The computer is yours. I can hold on to it. Just 1 second. Give me 1 second.
Good morning, everyone. I'm Akash Kumar Singh from National Taiwan University, and my advisor is Professor Patrick Shea. And before starting the presentation, I just want to let you know about have you many people already visit many times on construction sites, but have you seen any person who using some historical data? Anyone? No. Yeah, it's a common thing. Like the people start the project, they complete the project, but they just put the all construction data into their archive file and they never open. So what will the problem happening right now? I will show you in a very short video.
Every construction project creates knowledge, but what happens when it's never captured? Meet an experienced site manager, 20 years of construction projects, and 20 years of planning decisions. But project information is scattered. The plan in one program, the model in another, emails and reports elsewhere. The complete picture is written down nowhere. It exists only in his head. He connects it all, every single day. Past projects hold real knowledge, but no one can search it, so no one uses it. After every project, he played out more. Then the files never broken again. So the next project repeats the last one's mistakes. Rework, delay, costing time, money, and trust. The deepest knowledge is never written. How trees work around each other. How planets site, it stays taciturn. He is the best planner from past, but he can only be on one site at a time. Turn your plan into a schedule is where the real thinking happens. But only the final stage of the same. Not the logic, not the constraints, not why the sequence that way. When the plan walks out the gate, the thinking walks out with it. The next manager inherits the scope, not the reason. Scattered, locked in one head, forgotten. All the information exists. The reasoning is not. So what if that could be captured? This research proposes a neurosymbolic approach to construction planning. Large language models treat projects language. A knowledge graph composes facts, constraints, and language. Each strengthens the other, forming rapid, explainable reasoning. The goal is to capture the reasoning, not just the result. So planning knowledge can be structured, checked, and reused, project after project. Checked, reused, passed on. Construction is not short on knowledge. It keeps losing it. Now it doesn't have to.
So I hope you get the little bit idea what I'm going to talk about in next 20 minutes. So let's start with the big numbers. Like as you all know, like our construction industry, like from 2000 to 2020, we have increased from 7 trillion to 13 trillion of globally. But if you see the next space, it's also starting from like from 20 trillion globally. And if you saw the gap between the gap from 2 trillion per years, and like we have a missing 1.9 trillion in 2040, and if you see that cumulative way, it will be like a 15 trillion. It's not a small amount, it's definitely a very large amount. And we also see the growth from 2.6 to 3.2%. And one another graph, and also the studies from the Minsky, like they take some 500 projects they dig out, and they come up with this statics. Like every project started with the 100% of cost and also the 100% of the schedule, but actually it's end up with the 9% of the actual cost more, and 52% of also the in schedule delay. So what is they showing? Like it's also showing they become the like 1.79 billion is also trying to be more over budget. And in the times of scheduling is 19 months every delay of every projects. So this is also the one of the source from Minsky. And one more I want to show about the number. It's really, really important, and it's also very high, like motivate me for my research. Like out of 100 projects, like one project is equal to the 18 projects. But if you see over 95% project, they miss the deadlines and also the over budget, and only 5.4% they are on time. So it also shows a very high number to motivate us for coming with this kind of automation to enhance the construction planning and also increase the productivity of construction site. So where is the like problem? Like how the projects end without reasoning lead, without the planner. Like the hidden cost first was the planner hold the tactic knowledge. Like when they join a new project, they learn many things from the new project. They also come with experience from the previous project. But everything is in his mind, as also show in the video. But we never store their knowledge in terms of other data and in document. And second was organization is keep on only schedule. They don't know how to like actually plan for the sites, and also there is no reason behind their planning. And third was knowledge is lost again and again. Every project starts from zero. So what the schedule doesn't show, like we all have seen the construction schedule is made up by, but is never followed by construction site managers and site engineers. So we are considering six main structural, physical logic, temporal constraint, and resource crew dependency, cross-discipline coordination, quality inspection, and safety and permitting rules. So six interacting construction, we are familiarized to coordinate informally on site and beyond the limit in the manual planning at scale. So we have like many researchers, and I know like many of here also that you have done very good work, and really it's really appreciating. But we are still lack of some gap we have found from different criteria. Like if you talk about the reinforcement learning, we have a very hard filter and single objective. It's hard to learn from that data. And also, if you talk about the NLP and transformer, they also have a not grounding level reasoning part. And if we go for beam and rule based system, they have a limited transfer and also like a very hard coded rules behind the when you try to convert into a scheduling. And so fourth was the knowledge and LLM. Definitely, they are becoming more coming a very trendy topic, and also like they are very high phase of their very good plan to do it, and also like they have a very static, unvalidated, and prompt dependent lab. So like overall, there is no unified framework which can reason jointly and across the full spectrum of the execution constraint, with also justification for this. So what's the three challenges like AI is facing right now? Like the first was the check everything together. Like the people try to make a one decision, but sometimes it's making one decision create a whole plan wrong. Second was follow the real rules. Like they just not just predict the pattern, but also the rule first. They also try to predict the second pattern. So prediction is not the case we need it right now. And third was there is no reason in behind the every schedule. That's why the site managers, site engineers, they don't follow the schedule which come from the planner. So now, like why we are like coming to some not just a AI model, but we are trying to converting the planning expertise into a reusable intelligence. So we started with the neural network. Like definitely, they have a very good in learning or very flexible in planning season to make the any project context and examples. Like and also plus the symbolic. Like they have a very huge and good checking constraint and also try to make our rules and constraint methods. And fourth was the reinforcement learning. We have a very good reward modeling, like you can predict the reward based on the context which you gain from the symbolic graph and also the predicted by the neural network. So this is the like we have a kind of a choice design, like we try to rule or not the added data graph, but also try to guide the reasoning and evaluating the results. So this is our vision. Like we are in this paper, we are trying to implement it and try to getting our goal. First, we have our different documents already, like construction contract document, master schedule, project information, project specification. We then just try to extract the information using a base small language model. Why we are using small language model? We also more care about the data privacy and also don't want to spend more tokens on the priority models like OpenAI and Claude. So we are then try to convert our extract the information and try to convert it to a knowledge graph. But still they are very interconnected. So we try to train our own small language model, which can predict easily their relationship between each nodes, and they come up with some comprehensive knowledge graph for which we can use in a different part, like a software, also in BIM, 4D BIM, and also the project control system. So there is some problem formulation we try to do. We have a input, like we have a multiple discipline, work package, location. It's kind of a ontology, you can say. And we try to get some output of a more WBS knowledge graph, like which also consider the multiple information, like different relationship, different criteria, and also the more reasonable natural language reasoning of the each relationship, why they are giving why they are predicting the relationship, also the confidence score which come from the reward modeling. So here is the one example, like I try to make to visualize more clearly. It's a very basic small example. We have a like a rebar installation at site. So we were started with the rebar installation, but we check we have a structural dependency. Either is inspected by quality manager or not. But after the quality manager check, we also have a difference on the column cast and curing and temporal and also the formal site work. So overall, the four criteria are only one current plant, and every judge is specified and scored it. So this is our overview of methodology we are trying to creating. We started with some historical schedule we try to consider as a seed data, but historical schedule we are not very good quality, and we first we try to augment that knowledge graph which was started from the historical data, and then try to create more synthetic WBS generation based on project contracts, and then we try to use another model to create categorize the relationship with the reasoning and inferences. But we already have the whole categorized relationship with the different WBS, but still we need to try to evaluate that part. So we also try to evaluate by process reward modeling. I will show you in further slides. And then finally we come up with our fine-tuned small language model using GRPO optimization. So like later you can see, like if you have an unseen WPS directly from the document, it will directly use this model and they give you the explainable relationship graph. So we started with the first stage, like data, how we generated data. As we all know, data is very is not scarcity by the owner and client when you ask about the data, and it's very hard to get it from them. So we are trying to come up with a new idea like how to create our own data, but it should be also be validated or evaluated by ourselves. So we started with the synthetic data, how to extract the pattern from the historical schedules, and then we try to augment it. Like maybe most of the schedule are very incomplete or very not very good quality. So we also try to augment it. And then third was normalize the scheme. Like we are also try to make a standard formalization of ontology. So we also try to do it. And then like we are in this one, we are trying to take a 16619 task, which is unique from one project. Then second was multi-criteria relationship inference with the expert verification. In this, we try to first generate the reasoning behind the each WPS and their relationship. And we come with some category to by category with the domain rules. And then we use a PRM model. PRM model is basically is a process about modeling, which evaluate your synthetic data based on whatever you give the context on it. And we have a very few multiple expertise. They have a very few rubrics. They have a multiple criteria, and also they have a multiple metrics to evaluate this synthetic LLM data. And then we then validate graphs through the rubric passing and justification on the confidence scores by reward model. So we verified the 4033 verified relationship annotators, and every label check against the expert defined standards. So third was learning, how we learn from that knowledge graph data. So we come up with some 4-5 steps. Like we first the graph constant decoding, then we try to create more sampling, like eight times of WBS. So and then we come up with the compute composite reward. This is the main criteria we try to evaluating in our GRP method. Like we try to evaluate the correctness of the relationship structure and format, and also the constant in reasoning. So we also divide the different weight balance, and then we try to aggregate overall the rewards and complete with the update the policy parameter, which go again and again in a very cycle way. So people can take this model and try to, if you have a new project data, you can also give it to and try to again. But you also need to verify like they don't lose the previous training data. You also need to check it. So yeah, we take a data set like and training setup. Like we have a 28 WBS instance from a real residential project, and then we try to extract the 619 unique construction tasks. Then we generated, and then we have a 6 different projects we generated, like a structural system masonry and RCC composite precast steel and timber, and we use a Quen34B model, and we have a hardware and balance data. So this change is really mean for the real project. Like, so first was is the preserve expertise. Like we're trying to save the whatever the planner they have, how they try to save their knowledge. The people can use it later. Second was the standardized decision. We always come with the ontology or formalize the data. So can people also can generate and follow the same ontology to and evolve the framework. And third was transfer knowledge. Definitely the reasoning also is very hard to transfer to across the planner and also the juniors. So they can also utilize the reason what behind the relationship between or tax dependency. So they can see the reasoning behind it. They can also learn from it. And fourth was enable autonomy. Like we're trying to integrate with some other interoperable kind of software like BIM, maybe 4D, and maybe for other purposes. So now, like we started with some results. Like we have a training dynamics. These are the 6. Actually, it's 5. The last one is a total reward. We are trying to also sum up of this, and we can see that there is very. You can see that these are the 4-5 rewards we are trying to learn from this model, GRP processing. And then we have a second optimization stability. We also try to check like when it's failed. It's failed at peak 13.5 person. And then another graph shows how much the spike like we get from the GR per step. So the final overall summary is like we have a 13.5% final preference ratio and 1370 token per completion per WBS, because we have a limitation of if you know about the how LLM SLM work, like you have a token limitation. So right now we have a minimum stable in 1370, which is good. And then we have also a 25 to 30 second per instance. Like if you give one WBS and it will give within a 30-second your relationship category of your knowledge graph. And third was the more we are also trying to see how the model is more generalized. So we try to using the similar project, not the other project like infrastructure project. No, we are just trying to taking some other similar other projects of a residential project and try to evaluate it. And we found the every average is really good, but in terms of rule application, it's a little bit hard. And we try to improving this one also more. So the fourth one is the how the each criteria each reward is giving the good performance. So we have a 7 like scheduling, structural, temporal, resources, and cross discipline, and safety and quality. So if you see like the quality and safety are is really giving a very good, because they got the too much context of the project, so they know how to come up with the best criteria of relationship of the between the two activities. So this is just a demo, like what I'm trying to doing. I just try to just upload the document, then extract the information from that in a JSON format, and then they try to generate into knowledge graph. And then after this knowledge graph, you can see there is a no relationship right now. So based on the reasoning model, we try to generate the relationship between the different activities, different WBS, and then our train model works to connect all the knowledge graph and give it the final WBS category relationship with reasoning. This is just a demo, and still it's very initial phase. So what actually is new is here. Definitely the first is unified data symbolic formulation. Like we have a very we lots of tactic knowledge from the side, so we exploit the and also verify the constraints. And second was LLM driven data pipeline. We all know how much is hurt like when you don't get any data for your research. So yeah, right now you have we can utilize the LLM for that part, and we can also evaluate based on domain expertise to make a rubrics and metrics to evaluate this based on reasoning, because right now the LLM is also included in reasoning. And third was it's a reproducible reinforcement learning reference. Like it's not like we need to train again whole model with a new data set. No, if you have a new data, you just train the same model, and it will be evolved for based on the new project data. So yeah, like symbolic knowledge plus reinforcement learning is equal to the like explainable construction reasoning. What I saying? And now here's some limitation. Like definitely, I use only single project seed data, but I want to be more generalized of other projects also. And synthetic augmented maybe preserve some source domain based bias, but still I was also trying to more mitigate with using a PRM model. And third was the transfer to other projects, like how can we require domain specific constraint. It's also it's still in progress. And also the reference are generated, not the expert validated. We still need a validation from the experts. So where we are now moving, we are starting from the test across the different topologies and delivery concept, like different projects. And then we are also trying to extend the constraint framework and to a new domain and codes and methods. And also the uncertainty reasoning. Sometimes like it's come some incomplete reasoning. So we are also trying to mitigate the things. And the validator across the real world projects and disciplines. And definitely the last was the main one, the test planner trust, like which can be usable and adoption by the new real workflow. So what we can take from this presentation, maybe you can get some like how we are shifting from traditional planning to the reasoning engine from tomorrow. So like you can consider for your own research also, but right now I'm giving you the example you can better understand like how the planner reasoning state tactic how the record captured the outcome, not rationalized, and also the knowledge is really scattered across the people, outcome, data, information, documents, and tools. And each project is like every time they start from we learn from the zero. So now we are moving towards the reasoning engine. We have a definitely we have LLM. We can generate a structured data. We can generate a data we can which AI can learn and read it easily, and also the decision ground constraint tools and evidence. And the reasoning is also the explainable and also try to be reusable. And every project improve the next one, not the like they stop and put the all knowledge and every information in the archive file and never use it again. So yeah, the knowledge stopped disappearing at the project completion, but it become a cumulative research as an industry asset. So yeah, like the future of construction is AI is not a sterile generation. Definitely, it's a construction reasoning and knowledge preservation. So we are already few from the last few slides. We see how the tactic convert into the explain, learn plus grounding, and also the explanation and reusable. And yes, the construction knowledge does not have to leave when the planner does. So yeah, last I would like to thank the NSCC project in from Taiwan, and also thank to my professor and the EC3 committee for giving this prestigious award, and also the opportunity to present in front of EU professors, especially yeah, because last from 4 years, I follow many professors and I talk with them also, and it's very honor for us to see in person actually through this conference. Also, it's very like yeah, it's very good for us also. Thank you so much. If you have any question, just let me know.